people coming in to hear our speaker, which is great. I'll just give it another couple minutes. Morning. Does anyone know if they can hear this in the CLC? Oh, too bad. I went around to the tables, but yes, okay. All right, I think we can get started. So good morning. My name is Cynthia Carew, and I am the chair of the Creation Care Committee. Thank you all for being here. In her book, Sacred Nature, author Karen Armstrong says, "We need to recover the veneration of nature that human beings cultivated for millennia." This month, we'll hear from speakers who can help us see the sacred in nature all around us, beginning with the soil beneath our feet. Our guest today is Teresa DeMars. Teresa DeMars from the Rice Soil and Water Conservation District. Please help me welcome Teresa.
Thank you. So it's great to be here this morning, and I'm excited to tell you about some of the secrets of healthy soil. But before I get into the secrets, I want to tell you just a little bit about SWCDs, because a lot of people have never heard of what soil and water conservation districts are. We like to think that we're one of the best kept secrets in Minnesota. So we're a subdivision of state government, but we have the county boundaries of Rice County. So every county in Minnesota has their own SWCD. We're overseen by a board of 5 elected supervisors. So when you go to vote, you might see that single name and might wonder what they do, but they oversee our organization and make recommendations on what we should be focusing on when it comes to soil and water conservation and natural resources in the county. And our mission is to assist landowners in the management and conservation of our soil and water resources by means of educational, financial, and technical assistance. We kind of have a unique history. It goes back to the Dust Bowl days. So in the 1920s, farming was kind of exploding. We had the invention of the tractor, and so agriculture expanded on a wide scale. It was also a really wet period in the United States. So down in Oklahoma and the panhandle of Texas, farming really took off. When the 1930s came, that same area experienced a drought. And as a result, all the crops dried up, and the native vegetation that used to protect the soil wasn't there. So we had these massive dust storms. And millions of acres of farmland was damaged. And it was one of the greatest environmental catastrophes that we've ever had here in the United States. So President Roosevelt was tasked with trying to fix this problem. So he wrote to all the governors across the United States and asked them to create local districts that would work with farmers to implement conservation. And so Minnesota, the legislature agreed, and so they passed a law that created districts, and our district was formed here in Rice County in 1942. President Roosevelt also created the Soil Conservation Service, which is a federal organization that also is still around here in Rice County. They changed the name in the 80s. It's now called the Natural Resources Conservation Service, and we actually share an office with this federal organization. So we work together to get conservation on the land. So back to the secrets of soil. I have 3 secrets that I'm going to share with you today. So let's start with the first one. So the first secret of healthy soil is that soils are alive. Soil might not be the most glamorous natural resource that we have, but I hope by the end of my talk that I changed your mind and help you discover how incredibly complex and fascinating soil is. So a teaspoon of healthy soil can contain between 100 million and a billion soil organisms. So just think, in a cup of soil, there's more living creatures than there is life on Earth, pretty much. I mean, it is staggering. And so here's our first. There's like 5 types of critters that I'm going to show you today. So here's the first one, bacteria. So bacteria feed on organic matter and store and cycle nitrogen, and they also can decompose pesticides. So they're pretty important critters in the soil. Our next one is protozoa. Again, a microscopic creature. They eat bacteria and fungi, and when they eat fungi, they break it down in a form of nitrogen that plants can use. And nitrogen is one of those nutrients that are limiting in the soil, so it's really important. It's one of the things that helps make plants green is nitrogen. It's needed. So another creature here that's, again, microscopic are mites. They help to decompose organic matter. Nematodes. These are microscopic worms that are also important in the nitrogen cycle. Earthworms, which I'm sure you are all familiar with. They eat plant residue and have nutrient-rich manure. The tunnels that they make aid in soil structure and improve soil, that should be water infiltration. So it's really super important that there is space and air and pores in the soil for water to get through. And I'll talk more about that in a little bit. And finally, the one that I'm going to concentrate a lot on here today is fungi. Fungi in the soil it is amazing what they do. That's just fabulous. So mycorrhizal fungi, it's just the name that we give to them, and it's all that white stringy stuff that you see connected to the roots there. This type of fungi has a symbiotic relationship with plants. So they give nutrients in water to the plant in exchange for carbohydrates or food. And before I go into the next secret of soil, I want to show you a little something that demonstrates their action in the soil. Okay. So, I bet you never thought you'd be looking at underwear today. But this is a little something called the Soil Your Undies experiment. Okay, sure, that sounds great.
I also never thought.
So this is a kind of a popular experiment. So what I did was I took brand new underwear, and this underwear is made out of cotton, and cotton is easily digestible in the soil by all these little soil critters that live underground. So we went into 3 different soybean fields here in Rice County, and I buried these underwear in the ground, and then around 6 weeks later, I came back and I dug them up. And you can see that they're in various states of decomposition. So here we have this pair, it's pretty much intact. And that was in a field that's been plowed and plowed and plowed and plowed and plowed. And these 2 over here were in fields that had different conservation practices on them. One being conservation tillage, which in this one case down here, this was no-tilled, and that means that there was no tillage done at all. The farmer will plant the seed with a machine that just pokes a hole basically in the ground and drops the seed in it. So there's no tillage at all. And this one was in a field that was strip-tilled. And in this type of conservation tillage, the farmer just tills like a 5-inch strip, and the rest of the spot area is left, and the corn residue is left to grow, or left to mulch the soil. And then they also planted something called cover crops, which is a second crop that the farmer will plant, usually grasses and some other species, and that will grow in between the crop rows, and in the fall and in the spring it overwinters. So instead of there being bare dirt there, there's actually grass growing in the off season. And so that protects the soil. So those types of systems create better habitat for all those critters that we want to see in the soil that I just showed you. You have a quick question?
Do we know how, at least up front, are those farms that are practicing the sustainable methods able to compete with the other one, or is at least on the outset do they have fewer crops, or how does their yields compare?
Their yields are pretty similar. And I'll get into it a little bit later too. There's a cost to planting the seed and stuff like that, but then there's also a cost savings because they're not in the field as much, and they're not using as much, typically as much herbicides and pesticides. So I'll get into it more later. So thanks. All right, we're going to get to this next secret. Okay. And it has to do with this fabulous fungi here. Okay, so healthy soils also store huge amounts, have the potential to store huge amounts of carbon. So, and this is done through photosynthesis and the carbon cycle. So we have this equation up here is the equation of photosynthesis. We have the sun's energy, and the plants take carbon dioxide out of the air, they mix it with water, they take their chlorophyll and the sun's energy, and we end up with sugars or carbohydrates and oxygen. So the plants actually send a lot of these carbohydrates down to their roots, and the roots exude out these carbohydrates into the soil. And those carbohydrates feed all those microscopic critters that I talked about, including the mycorrhizal fungi. So here is a picture, might be kind of hard to see, but here we have the roots. Right here there's a root, there's these browner parts are the roots, and then you see all this white tissue-like stuff that's covering those roots. Those are the mycorrhizal fungi, and they give nutrients and water to the plant roots through something called hyphae, and hyphae is that white stuff in exchange for those carbohydrates again. So along with that hyphae, the fungi produce something called glomalin. And that's a sticky compound that coats those hyphae and protects the nutrients during the exchange. So the glomalin is like a glue, okay? It's very sticky, and it's long-lasting. So the hyphae kind of change with the roots. You know, the roots are kind of moving, they're branching out, they're growing, and so the hyphae is kind of breaking apart and growing again and breaking and growing and breaking and growing. And this glomalin gets released into the soil, okay? Okay, so along with that, you have all those other soil organisms. And as they are living and reproducing and dying, and they keep on doing that. And at the same time, we have the sun and the carbon cycle happening. We have the carbohydrates being exuded out through all those roots. That brings carbon out of the atmosphere and into the soil. So here we have soil forming and building carbon, or another word for carbon is organic matter, okay? So we have, I'll read this out. As soil organisms organisms live, reproduce, and die, they release carbon. The carbon gets stored in soil aggregates, or right here's a sample of an aggregate. So we have little pieces of like sand particles, and we have clay particles, and here is our little piece of carbon or organic matter. And then we also have air in that aggregate, and they all kind of stick together because of that glomalin. So the carbon gets stored in the aggregate. This occurs when tiny particles of soil clump together, sheltering carbon particles inside them. The glomalin acts as a glue and facilitates the soil aggregation to happen, the clod to come together. Yes?
I have a question I probably should have asked earlier.
Okay.
We have a garden outside our condo, and I threw the coffee grounds on, throughout the winter, and that's, what connection does that have with attracting earthworms?
Sure. Well, the coffee is an organic material, so it's going to go into the soil, and all these soil critters are going to start breaking it down, and then that's going to, in addition, the roots are working, the plants that are growing are working around it, so it'll get incorporated into these soil aggregates, these soil parts that are gluing themselves together. Okay, so let's see, what's our next slide? Okay, so this healthy soil will build and store carbon if it's left undisturbed. If it gets disturbed, if it gets plowed up, then all those carbon pieces of carbon are exposed to oxygen, and decomposition happens, and then instead it gets released back up into the atmosphere. Also, so if we don't have the plants growing, we don't have the mycorrhizal fungi, we don't have the glomalin to stick stuff together, and so that can lead to soil erosion if we have bare soil. So I'm going to do a little experiment here that kind of demonstrates that. Hopefully it'll work. So I have a couple of soil clods, which is a group of aggregates, and one of the clods is from a field that's been plowed year after year after year, and the other clod, the other soil piece, is from a field that has had conservation tillage on it, so it has not been tilled. So we're going to stick it in the water, and we're going to see if they hold together. So the one that has not been tilled should stick together better. So let's see what happens. So here we have a clod that has been plowed a lot. Stick that in. Put in there. And here we have one that has not been tilled. So we'll see how well they hold together. So what we should be seeing here is, because there's less glomalin or glue in the plowed one, that one should fall apart faster, and there should be less left of it than this side. So we'll just let that go, and we can come back to it and see how it's doing over time. All right, while that's stewing, we will look at the third secret to healthy soil. So the third secret of healthy soils is that they lead to clean water. And The reason why this occurs, I've been talking a lot about how it's important to have space and pores in the soil for soil to move. So if we look at well-structured soil, they have, here's the soil aggregates, and in between are these pore spaces. That allows water to move through. So if we don't have very much space, then water can't get through. And if we're tilling a lot and driving over our soils a lot, that can lead to compaction. So I have a couple examples of compacted soil. So as you look at this, I mean, you can see the soil, and if you look at it, it's almost hard like cement, the top of it. And you can tell that it's really squeezed together at the top just by looking at it. And so if there is zero space for the water to get through the soil, where is the water going to go? It's going to run off, exactly. And so that's what we don't want, because that leads to tremendous amount of soil getting into our ditches, and then it gets into our streams. And along with the soil are all kinds of nutrients like phosphorus. And when phosphorus gets into our lake systems and stuff like that, we get algae blooms, because in water, phosphorus is the limiting nutrient. So what we do is work with farmers to try to do things that will protect the soil. And so what we try to teach people are the 5 principles of soil health. So they are to armor the soil, to keep it covered. So that means residue. That's what's happening in this picture. We have some conservation tillage being done. So there's no tillage at all. So here we have the soil covered. We have last year's corn crop that was left behind after harvest. And then we also have cover crops growing. So here's the second crop that the farmer planted, and it's growing, and it's covering and armoring the soil. The next principle that we try to teach is to minimize soil disturbance. Like I said before, if you're plowing, you're destroying the habitat for all these healthy, these microscopic organisms. You don't have the plants and the fungi, so you're missing the glomalin, which is that glue. So we don't want to disturb the soil. We encourage farmers to use plant diversity, and that is, again, through cover crops, because different plants do different things. One really popular cover crop is called, comes from the brassica family. It's called radish. And so these radishes get planted, and they won't overwinter, they'll die, and then they kind of decompose later on. And what they do is they create a lot of tunnels, a lot of that airspace that I talked about. And so that helps with the structure of the soil, and it helps with infiltration. The radish, it actually gets the nickname tillage radish. So it's like doing green tillage. You're doing tillage with plants instead of a plow. The 4th principle is keeping a continuous living root in the soil. So we're keeping the plants growing throughout the year to feed the soil and hold on to nutrients. And then the 5th principle is livestock integration. So livestock manure provides bacteria and microbes to the soil, and also fertilizer, nutrients for plant growth. And this whole thing, these principles, it kind of has to do with mimicking nature. You know, 150, 200 years ago, we had 50 million buffalo here on our prairie soils. So we had plants growing, we had animals. It was a system that works. And so we're trying to mimic that also in this type of agricultural cropping system. Okay, so let's take a look at some of the common soil erosion problems that we have in Rice County. So this here is an example of wind erosion. So last February, actually, me and a colleague, we went out across the area. We went just east of Dundas, and then we went out on 246 and around Highway 60 east of Faribault. And we visited sites because we had lots of people telling us we had a lot of dirt in the ditches from wind erosion, and that's what we're seeing here. Here's a field that's been, it hasn't been completely plowed, but it's been ripped, which is kind of a more aggressive tillage. But all right here, this is soil that's in the road ditch. And so that's something that we totally would like to prevent. And the fix for it is, and this will be a common theme here, is no tilling or conservation tillage and then planting cover crops. We can fix that. If that field had that, there wouldn't be erosion happening. Okay, a second type of erosion that's pretty common is something called sheet erosion. And so this is there's a slight grade, but not much, but you can see just like this plume of where the soil looks a little bit different color. That's soil displacement from water moving. So that, again, that kind of erosion, the soil's moving and we'd like to prevent that. And so again, conservation tillage and cover crops would be the fix for it. Okay, the third type of erosion is something called rill erosion, and that occurs like in between the rows of crop that are growing. It's probably kind of hard to see in this picture, but the farmer was planting up and down the hill right here, and you can see like a different color line here and a different color line here. That's erosion that's happening in between where the rows of crop were planted. So it's a little bit of a depression, a concave depression, and so the soil's moving, so we want to prevent that. Again, we can fix that through conservation tillage and the use of cover crops. And then the final type of erosion that's pretty common here in Rice County is called gully erosion. So here we have, like after a heavy rain, the water will drain off and it kind of drains down to the lowest point, and it's almost like a temporary stream that pops up during a heavy rain, and it really cuts out. It's fast action. So if there's nothing armoring the soil, if there's no soil structure, it can just carve out a gully. And so we have some structural practices that can fix that. The first one is a grassed waterway. And so what will happen is they'll bring heavy equipment in and they'll shape out this area so that it's a little wider and there's a little slowly in grade, so it goes down. And then when heavy rains come, the water will flow on this grass part. So the grass is planted and the farmer just doesn't farm that grassed waterway. They will leave it. Sometimes cover crops and conservation tillage can take care of a gully issue, so that might be an option. And the third thing we do is something called a water and sediment control basin. And that is where, again, heavy equipment will come out to the site and we will build a earthen dam, and then we'll put a tile intake in front of this little earthen dam. And when we get a heavy rain, the dam will back up the water. It'll go into the tile intake, and then there's more tile downstream, so the water will flow underground through tile instead of flowing over the surface of the soil, and that helps to prevent erosion. I've talked a lot about the benefits of cover crops and conservation tillage. So I wanted to, or I've talked a lot about cover crops and conservation tillage, so I wanted to share some of the benefits. Again, it reduces compaction, which I talked about. Here's that radish, tillage radish I was talking about. So you can see it can break through the soil and create these air pathways. It helps with infiltration. It helps to control erosion. A lot of our farmers talk about seeing weed suppression because you have this. If you have this established, it's harder for weeds to start to grow. There's potential for grazing. So if a farmer has cattle, it can be grazed or it can be even cut and baled. So it's a feed source. It increases the organic matter, like I just explained before, how it stores that carbon through those fungi. And the living roots hold on to nutrients, especially nitrogen. Because it's good habitat, it increases soil biology. So there's lots of benefits. So if I'm selling you that cover crops and conservation tillage are really great, so why don't all farmers do it? more do it. We have like I want to say like 6 or 7% of our fields in Rice County have cover crops on them. There's a higher percentage that have conservation tillage, but cover crops, it's a fairly new practice. So some of the barriers. So for cover crops, it's an added cost of around $55 an acre. So that's like $4,000 extra seed costs for a field. Again, the other conservation things I talked about, a water and sediment control basin, those structural practices to fix a gully. For one of those, it's about $4,000. For a grass waterway, it's over $4,000 for a 1,000-foot waterway. A strip till machine for that special type of conservation tillage, $150,000. That's a used one, so it's very, very expensive. And then a cover crop enter seeder, anywhere from $10,000 to $20,000 that can cost. And then also, it's a complete change in management. It's almost like a lifestyle change because, first of all, it's a very complex practice because there's many different ways you can seed it on. You can interseed it, which means you plant it while the crop is growing. You can drill it in. It can be broadcast. It can be applied by airplane. That's a common way that it's done here in Rice County. And then there's the weather is a huge factor in getting cover crops to germinate because the majority of the time cover crop seed is broadcast. And so you need a little rain, like the perfect rain. It can't be too heavy, but you need some to get that seed to germinate. So imagine like this last couple of years, some people who tried it, it failed. So imagine spending $4,000 on seed and it doesn't grow. So that can be really frustrating, and then people will want to give up on it. And then also terminating it. In the spring, the cover crop has to be terminated. And so usually that can be done by either cutting it or usually the way it's done is Roundup is applied. But that is also weather dependent. And when you're planting, if you have a wet spring, again, you're playing with time, and that's nerve-wracking. It's a risk. So between the financial risk and the variables that are involved, and then there's also societal pressure. Because there's a lot of people out there who believe that if a field is not plowed, it's not being taken care of. If why are all those weeds growing out there? And so farmers who are doing this, they're they're getting a lot of looks from their neighboring farmers and other people that think that they might not be taking care of the ground. So all these things, the risk, the thought processes, the amount of management, it's a whole new way of farming, a lot to learn. It's not the way Dad did it or the way Grandpa did it. I mean, that's the reason why it's kind of slow in being adopted. But that's one of the reasons why we're here. Our office is here. We're going out to these places, and we have several different programs. We have programs. The federal government has a ton of programs where they try to give an incentive to take away some of that risk and to try to make it easier. So one thing we've done at the district is we bought an interseeder. We bought the equipment, and we go out. We're available where if a farmer wants to try it, and that's usually how people get into it. They start small because it's got a learning curve. You got to get comfortable with it. So they can hire us, and we have seed mixes, we have the equipment, we have the tractor driver, and for a very fair rate that just basically pays for our staff time, we can plant the cover crops for them. So they don't have to make that $20,000 investment in equipment right away, right? And then we also have an incentive program that provides anywhere from $30 to $40 an acre to help pay for the cost of seed, pay for the cost of planting it, that kind of stuff. So there's not as much financial risk to the farmer. And the same thing there's lots of federal programs that have similar incentives so that for 3 to 5 years, farmers can plant the cover crops and experiment with this new farming practice. So, a couple of things you guys can do to promote soil health and healthy soils. One thing you can do is you can even try using cover crops on your garden. Basically, it kind of works the same way after you clean out your garden bed. There's certain species you can plant and just let them grow late in the fall, and then you can terminate them in the spring, and it holds on to those nutrients in your soil, and it can also return some nutrients to the soil because you're keeping. You can just you could even plow, or not plow, but you could till those greens in there too if you wanted to. It'll be there. At least it's holding on to some nutrients. Or you can cut it and just plant right into it, just like the farmers do. A second thing you can do is to ask your local legislators to support soil health initiatives and the funding of SWCDs. And that's happening right this time of year. In March, the legislative session has just started and goes to sometime in May. And the interesting thing about SWCDs is even though we are a government organization, we have no taxing authority. So we're one of the few organizations that we can't raise any money through taxes. So we get money from the county, and we get money from the state, and there's a tiny bit of federal. It depends on certain grants. We just depend on grant funding pretty much. So we'd appreciate, getting a good word to our state legislators. That always is very helpful. And then the third thing you can do is, if you have land or even in town here, is to plant native trees and plants. They both have amazing root structures that go deep into the soil and control erosion and create really good habitat for all these amazing creatures to grow. So, and we actually have a native plant and a tree sale going on through our office too. So I brought some native plant order forms if anybody is interested. You can learn about that program. So any questions? Yes?
How does it, after 3 to 5 years, how does that compare to the fertilizer they have to use? And we've already established this, how much difference does it help in the crop without the fertilizer not getting that cheap?
Yeah. They're still dependent on fertilizer because it takes, cover cropping, it takes it doesn't happen overnight where you're building up that organic matter. It takes years. But especially when growing soybeans, that's when our farmers are really noticing a nutrient benefit, because those cover crops will get terminated in the spring, and then right around August, they'll break down over the summer, and right around August, they start releasing nitrogen, and their soybean crop will see a bump of growth in the August. So when it comes to yields, soybeans generally, they see a bump in yields from using cover crops, probably like 4 or 5 bushels. And with corn, sometimes they even see a little drop in yield. So, but in the end, it all evens out, and over time, our farmers are reporting that their soils are becoming more resilient with using cover crops. So in these drought years, and when there's better infiltration, so when it rains, they're getting more water at those times of the year. So overall, the farmers that are doing cover crops are definitely, they want to do it, even without the programs. The ones that have a lot of experience with it, they see the value.
I don't have a question, but I think the most important thing to say is that we can't ever make more soil. We can't get any more, right?
Yeah.
That original plant, or the original soil that came before the glaciers and the breaking up, that we only have so much, and so all we're doing is enhancing or trying to keep what we have.
Right. Well, yeah, we've lost a lot of topsoil. There's no doubt of that. And unless we prevent that from happening, there are like hillsides, some of these real erosive hillsides that have lost their topsoil. That's why when you drive in a field and you see a plowed field where the hillsides are a different color, they've lost some of that topsoil. But with the use of cover crops, you definitely are protecting, and they can build some of that back over time. So.
With that organic matter, but I even heard some of the extension people saying that they're really beginning to look at a lot of the things that are happening in our lakes, especially. It's the property owners, gardeners, that are causing some of the runoff, not just the farmers.
Sure.
With our own gardens and the runoff even within our towns, to really gardeners and lawn care people to really pay attention to that.
Sure. Yeah, well, all those things have an effect. And with lakes, there's a lot of septic systems too that are out of date that can have an effect. So we all have a role that we can do. We're all contributors. It's not, and I hope I'm not painting that farmers are doing. We're really lucky, I'd say. Rice County has been a leader in conservation for the state, so I'm proud to be in this office. And I worked here 20 years ago. I worked for the district, and then I moved away because my husband got a different job. And then we moved back, and I worked with the district again. And back then, it was amazing how many things were happening. And today, too, it's a little bit more of a push for the cover crops, but we have a really great conservation history in this county. And actually, with the Soil Conservation Service, Rice County was the Federal Soil Conservation Service back in the 1930s. They actually had places across the United States where they had demonstration sites where they did special experiments and were trying to get conservation developed. And in Prairie Creek watershed here in Rice County, we actually there was 4 demonstration sites in southeastern Minnesota, and Rice County had one of them. So our history of conservation really is strong. So, okay, yep, sounds good. Yeah, so this one is, if I shake it, it really went. Let's see what happens when I shake this one. It's holding together a little better. I mean, a lot of action. It's taking longer to dissolve. So yeah, that's that glomalin, that glue, sticking it together. All right, well, thank you so much.